Real-time feedback into the behavior of your distributed systems and observing changes, exceptions, errors in real time allows you to not only experiment with confidence, but respond instantly to get things working again.
Hello everyone, my name is Boiko and I work as a Serverless Specialist Solution Architect at AWS. Today I'm going to talk a little bit how to implement Backend for Frontend pattern with different AWS Serverless services. Let's together remember what it means and what it is about this Backend for Frontend pattern. Essentially, it was invented and suggested by Sam Newman several years ago, and the idea behind this pattern is to provide a certain layer of abstraction which allows you to build and to consume data from downstream microservices and to present it for the front end. How it looks like. So usually different teams will develop different types of front ends. It could be web applications, it could be mobile clients, and those different types of applications, they sometimes will need different types of data, or they will need different variations of data depending on different requirements. If we imagine the situation that we produce different front ends, so there probably will be different teams doing that. So there will be a team producing a web front end and a team producing different mobile front ends. And if we don't implement this backend for front end pattern, essentially that will mean that those teams will go directly to different microservices to consume that data. And this means that those services will be tightly coupled to the implementation of those microservices. And if you will need additional data, probably you will need to write additional logic on your front end. And essentially, it may mean that you will spend more time integrating your front end with different backend services. And the idea came here is to implement a simple layer, which we called backend for frontend on the backend, which will be responsible for implementing these integrations and consuming data from different microservices and then presenting that data to the front ends. And this brings a lot of benefits because now the front-end team will own this backend service, and they can easily change it, implement different logic and implement different presentation for different front ends. But on the other hand, the front end itself will have like a one particular endpoint to connect to and to consume all the necessary data and to have all the necessary interactions. It will decouple your front end from the backend services, and it will allow you to modernize front ends and change them quickly. Also, depending on different requirements, this web backend for frontend and mobile backend for frontend may communicate with different services and store different set of data. But how you can use and build those backend for frontend implementations with AWS? And specifically, I'm going to talk today more about serverless implementations, because I believe This is, in many cases, the most suitable way of implementing backends for frontends pattern. First of all, what does serverless mean to you, and why it brings additional benefits when you start implementing, for example, backend for frontend solutions on it? First of all, as it implies, you don't need to spend a lot of time on managing the infrastructure, to provision it, to patch it, and to do all the things. It is done for you by AWS, so you can focus more on writing some code, tests, implementing data storage, and in the end, producing the necessary functionality faster. Another very important characteristic of serverless is that of automatic scaling. That means that essentially you don't need to think a lot about how your service will scale under the load, and if you have like different spikes of traffic, how you should implement additional resources and provision them. It will, in many cases, done automatically, and if the traffic goes down, the serverless services will scale down automatically as well. Another very important thing here is highly available and secure configurations. Again, because we as AWS built those services, we already implement them in a well-architected way. We implement a lot of availability and security best practices within those services. Of course, you will need to think about availability and security, but at a much higher level, so you won't be thinking about how to patch, for example, operating system, how to implement some security controls on the network traffic. So these things will be done automatically. And the last but not the least important characteristic of serverless is that you pay for what you use. So if you don't consume any serverless services at a given period of time, you will pay nothing. But again, it is very important, especially for development and test environments. So you can have dev environments for each developer to try things out, or you can run different tests at a fraction of cost compared with traditional infrastructure where you will need to provision and have servers or containers infrastructure. But let's look how you can implement and essentially we have a big serverless portfolio which allow you to implement business logic, to store the data, to implement synchronous and asynchronous communication between different services, and implement security and development features. But let's look how we can start implementing our backend for frontend with this set of services. Probably the simplest and the easiest way of doing that is to have an API gateway as a front-end door, implementing and exposing a RESTful API for your front-end. Then having a Lambda function or a set of Lambda functions, implementing business logic, implementing different transformations, and a DynamoDB table where you will store all the data necessary for your particular front-end. But what is missing here? For sure, as you remember, you will need to interact with downstream microservices and get some data out of there. How you can do that? We can have different microservices running in our backend owned by different teams, but then we will need a set of event consumers which will either get the events in an event-driven architecture from those microservices, or going explicitly to those microservices, querying them and storing that data into a DynamoDB table. Let's look in the details how you can approach implementing those event consumers with, again, AWS services. The first pattern we will look into is event-driven pattern. So if your downstream and backend microservices already using event-driven architectures and producing different events, probably you will be using Amazon Event Bridge as event router, and those events from those backend services will be sent to the event bridge. And in the event bridge, you can define different rules to match a particular set of the events you are interested in. And then if those events match those rules, they will be, for example, directed to a Lambda function, or again, we have different destinations. And for those destinations, you can store those events, process them, change them, and in the end, again, store in a DynamoDB table. Another scenario you can think of how to populate your DynamoDB table with data from backend services is to implement a webhook. Again, when you implement a webhook, usually a webhook is a quite simple web endpoint which responds to GET or POST requests with some data in them. And the simplest way how you can do that on AWS is to implement those endpoint with a Lambda function. But Lambda functions, they have additional functionality added quite recently, which is called function URLs. And this functionality allows you to expose your Lambda function directly via an HTTP endpoint. So you won't be needing an API gateway here to create such a webhooks. And then you can get that, you can send that HTTP endpoint to the teams implementing this or that microservice, and then they will send HTTP requests, GET, POST, PUT, or whatever you implement and how you agree with those teams and send the data to your Lambda functions directly with HTTP requests. And then again, in your Lambda functions, you can implement additional business logic. Maybe you will transform those events to another view, or you can again enrich them by going to and querying additional microservices in the backend. And then in the end, you will again store that data in a DynamoDB table. Another pattern which is quite common, if the downstream services can't produce events or can't send HTTP requests in the form of webhooks, probably they still have some kind of APIs or interfaces you can query to get the data for your front end. But here you will need some kind of a polling mechanism, how you will initiate connections and query those microservices. The simplest way to do that is to utilize Amazon Event Bridge Scheduler. So you can, with a scheduler, you can schedule producing some events, and those events will trigger a Lambda function. And again, with scheduler, you can schedule events to run periodically, maybe each minute, each day. You can even create a cron job expressions and identify how often those events should trigger. And then once they trigger, they will invoke a Lambda function. And again, in that Lambda function, you can implement a business logic, a connection to the downstream microservices, to different APIs. It could be, again, a REST API. It could be a gRPC API. It could be maybe go into a particular queue and get some messages out of that queue. Again, depending on the contracts exposed by those microservices. You will consume that data into a Lambda function, and then you will again transform it or save as it is or enrich by making additional calls to the additional endpoints and store that data into a DynamoDB table. So now we already have quite capable implementation for our backend for frontend pattern. And yeah, we can consume and get interesting data and necessary data for our front end from different resources, from different microservices, either by schedule or by the webhook or implemented an event-driven architecture. And all that data is accumulated in our DynamoDB table and then can be consumed through a REST API by our front ends. But if we want to go into production, for sure we need to think about additional things like security and observability and add those features before we make our service publicly available. For security, for sure you will need to implement authentication and authorization in many cases. And we have a service which is called Amazon Cognita, and your front end can go there and present a login form, and your users will log in via Amazon Cognita. The front end will get a JIT token, and then you can use that JIT token to authenticate into Amazon API Gateway, and API Gateway will check the token and either provide or deny access to the endpoint. Another very important thing, especially when we're talking about different types of integrations, is that probably if you go in to query this or that microservice, you will need to store maybe an API key or some credentials or other secrets to interact with those services. And for sure, it's a bad practice to hard code that things, and you will need some kind of a mechanism where you will securely store all that secrets and get those secrets only when you issue a particular calls to the downstream services. And for that, you can use AWS Secrets Manager service. And another very important thing when you go into production is, of course, observability, because we want to know how our service works and whether there are some issues or not, and we want to act upon any kind of problems or things happening with our services. And for that, for sure, we need to implement observability. And again, the simplest way of doing that is to use CloudWatch and X-Ray services, and all services like API Gateway, Lambda, and DynamoDB, they send logs and metrics to CloudWatch, where you can then go and look for logs and metrics. And also you can enable integration between API Gateway and Lambda with X-Ray. And X-Ray allows you to make traces. So if the request comes to the API Gateway, it will generate a new trace ID and send that information to the X-Ray and pass that trace ID to a Lambda function. Then a Lambda function will make some calls to a DynamoDB table or make some other things. And all that information will be recorded in an X-ray, and then you can get a trace that this particular request went through API Gateway, Lambda function, and a DynamoDB table, for example, and you can look whether there were some bottlenecks, issues with that request or not. Another thing I wanted to present you a little bit in terms of serverless services and backends for frontends is a service called AWS Step Functions, and how it can also help you to implement your backend for frontend pattern and in what scenarios it can be useful. But at first, what step function does, it is a state machine which consists of different states and transitions between those states, and allows you to implement different workflows and orchestration patterns in your application. It has a number of benefits because it has a visual representation. You can quite easily and fast build prototypes and integrate with different services. Again, it has a lot of built-in integrations, and you won't be writing a lot of code for maybe simple transformations. For example, if you want to run some actions in parallel, for example, querying different APIs at the same time. If you want, for example, have some scheduled actions, timeouts, it is already built into step functions, so you can write much less code to implement those interactions. And you can use a visual editor to model your workflows, and then there's monitoring features which allows you to see how those workflows behave. And let's look at an example how you can utilize step functions to implement different workflows for your backends for front-end applications. Let's imagine an example case where we are building a booking service, and in that booking service we will need to, for example, book a flight, a hotel, maybe rent a car, and add maybe some additional things, and we want to book this travel as a whole, because, for example, if I can't book a car, probably I'm not interested in going to Grand Canyon, or I'm not interested in a flight if I can't book a hotel. But if I already booked a flight and can't book a hotel, there should be a mechanism to revert all the previous steps. And usually it is implemented with a Saga pattern, which allows you to roll back different actions and use this sequence diagram to implement some kind of a distributed transaction when you need to interact with different services, for example, book hotel, flight, and rent a car. And if something goes wrong at each step of this sequence, you will need to have a way to revert everything back. And the Saga pattern is an implementation of such approach. So, for example, if in my workflow book flight fails, I already booked a hotel, but I'll also implemented a cancellation logic, so rollback logic to cancel hotel. So once my book flight call fails for some reasons, I can go and cancel hotel booking. And these workflows you can easily implement with step functions. And a good thing here is that step functions can be even integrated with API gateway, and you can integrate them directly. So, for example, if you want to build some kind of a workflow for your backend for frontend and present some data, accumulated data from different microservices, or orchestrate calls to different microservices, aggregate some data and then send it to the frontend. You can do that easily with step functions. So you can make different calls. You can make those calls sequentially, or you can make them in parallel. For example, if you want to just query several endpoints simultaneously, you can use parallel execution, and then you can get all the responses back and aggregate them, and via API gateway send the response back to the customer. So it is quite powerful service, and you can implement different workflows with step functions. And the good thing, as I mentioned, there's synchronous invoke mode, so you can use it for real-time or close to real-time interaction. So I make a call, step function, state machine start executing, get some data and return those data via API gateway. Or you can also use them asynchronously, so a query comes, asynchronous invocation starts, maybe doing some updates and things, and the response is sent immediately back to the caller that, yeah, we got your request, we start processing that. So here you have different ways of implementing such interactions. Also, to conclude my talk, I wanted to share a couple of interesting and useful resources and links. If you want to learn more about microservices, about different patterns, a well-architected framework, and also some sample code, how to implement business logic in a form of Lambda functions with, for example, TypeScript, which is quite common language for the front-end developers. There are tons of samples and things you can utilize to start developing your serverless backend for front-end applications. And again, you're not limited only for implementing backend for front-end pattern. You can use serverless services to implement any other microservices, and even you can use them to implement backend for your micro-frontend applications. So we have a set of new articles and examples produced by my colleagues, how to deal with and how to build micro-frontends on AWS as well. With that, thank you very much. And again, if you will have any questions, you can reach me on Twitter, and I will be happy to discuss any kind of projects you have in mind to build on serverless.